Hello everyone. In last lecture we have discussed the flexible manufacturing system part 1. So in that lecture we discussed about the history, introduction, the FMS, flexibility, classification of FMS part. In classification we have discussed single flexible manufacturing cell and flexible manufacturing system and basic components of FMS, that is workstation, automated material handling, computer control system, and human resource. So till two basic component we have discussed. So now afterward we will discuss the components of FMS. So this is the third component of the flexible manufacturing system, computer control system. So before starting this system, we will discuss the computer control programmable logic control, because in every machine system, every manufacturing system or which is automated having PLC, program and logic control. So we will see the basic component of PLC, how it works, what are different components. So majorly we can see there are main parts. PLC are one PC for PLC programming. Then this is the input lines where we give inputs to our system. So as a you can say as a input devices we use sensors, transducers. So these are terminals through which the inputs are given. Then there are output lines or output devices. So as a output we use like limit switches or kind of like you can say motor, servo motor, solenoid valves, that kind of things. So another components of this PLC is your main computer CPU part. This is the brain of the PLC part where all kind of programs or problem is solved, and then memory where all the program is saved. Then power supply which gives backup to each component. Then communication. So as for communication between your programming computer to your CPU or memory, we use RS-232 cable. That kind of communication line is used. So this is the whole PLC system which is being used in every machining system, automated machining system, or used for controlling the different components of the system. So in computer control system there are major components or parts which have major roles. One is workstation control. So majorly we have already seen that in flexible manufacturing system there are multiple workstations where different operations are carried out. So there is communication in different workstations. So that control of flow of different component to one station to one other station is required. So that is one type of control, workstation control. Second is supervisory control among workstations, workstation coordination. Again, same like, so we in a wall nut set we see the how the things are going in different workstations. So that kind of control. So each control, and we say like we in a system we have 5 workstations though. So 5 workstations at once we supervise or we observe. So that kind of control. Third is production control. So here we see the how our parts are moving, how much quantity we are doing, we are making the parts, or the parts is flowing. Fourth component is traffic control. So traffic control means we can see in each workstation how these parts are moving and how much quantity is there. So we need to see that there may be like not much quantity of products are kept in one system. So fifth system type is shuttle control, that is part handling between machine and primary handling system. So because in automated guided vehicles or for moving the components we use some kind of shuttle system, or where we need to control that thing to handle the different part from machine to other machines, that is part handling system. Sixth control is workpiece monitoring. So we see the uh, where we monitor the workpiece, specifically the different components of one workpiece, how to monitor how these are things are happening or what different operations are performed. So one is tool control. So specifically the tools which are being used in different machine tools, we monitor the tools of different machines, their locations. We can say the major that parameter tool life, that is we see or we observe through some kind of sensors, and we, we derive the tool life of the different tools used in some machine tools. Then we observe the performance of the machines or workstations, and we monitor and we report, and we do analysis whether the performance is up to the mark or not. Then diagnostic control system, where we if we have some kind of error or some kind of problem, then we identify the source and we do rectification. If we have some kind of maintenance, we need maintenance, then to avoid some kind of breakdowns we do preventive maintenance. Now we can see or this flexible manufacturing system control system, how the different that components, as we have discussed in previous slide, are connected within one industry. So like we have one factory where are different automated machining system which are working, and the parts are moving from different workstation, and we are getting end product. So this is one layout of factory, and all these are controlled by your FMS computer system. We can say FMS control system. So we can see the two major components, that numerical control part programming and that one major host computer. So using this part programming, we do programming and we generate some kind of codes, and in terms of numerical control, that for each kind of control, for workpiece related, for transport related, for machine control related, for a specific tool we create, or we create program, and for production control also we do programming. So all these are done using the part programming. Then to see the data or to see the related activities, we or to control the related activities, these are handled by your system management. So these all FMS control system work for an industry, and as per these programs, our automated system, automated workstation are worked, and we get the desired output. Fourth component of the flexible manufacturing system is human resource. So we need to understand that uh, whatever we will get the automatic system, but still we need some kind of humans or skilled labors to manage the all activities. So humans are very much needed to manage the operations of FMS. So particularly some kind of functions which are performed by human only, that are loading the raw workpieces into the system and unloading the finishing part, that are done by the human labor. Or we have some certain assembly which are not being carried out some kind of robots, then there is required some kind of skilled labor. Then changing and setting the tools in the machines or CNC machines for different varieties operations, we need human labors. Again, for equipment maintenance and repair, we need human labor. If we have certain breakdown in an equipment, then we required to see the labor, that whether the system is performed well or not, means for getting maintenance or repairing that we need human. For NC part programming and machining, if we need to develop a part manually for certain operation, then human or skill labor is. So in this slide we will discuss the different layouts in flexible manufacturing system. So majority we have five types of layout. One is progressive or line type layout. Second is loop type layout. Third is ladder type layout. Fourth is open field type layout. Fifth is robot centered type layout. So we will discuss one by one. First is progressive layout. So in this layout, we will see that different machines or the machining units are arranged in one line. So this is the place where we start our process, means we feed or we load the raw material or workpiece. So one by one each operation is performed for workpiece that required operations. Then finally we get our finished component and we unload the complete parts. So this is the progressive, or we say line type layout. So where each operation is performed step to step and we get the end product. So basically this progressive layout type is best for producing a variety of parts. If we have different variety of component, then we use this kind of layout. Second type is loop layout. So in this particular layout, that design is like a running track. So in a loop, the machines are arranged. So we will see in this layout that at one point the loading and unloading of part is carried out. So we can say this as a raw material we load from here and they start moving from this direction. So first we will do some kind of operation of this workstation, then do some different operations to different workstation. So after some operations that we will move our piece in that way. So again we get some operations. So the required operations performed by the different workstation. Then finally we get the workpiece, and in the end we get inspected the component produced. So once we inspect and we get that our workpiece is as per desired, so this workpiece is unloaded by the same point. We get the end product. So we do this process in a loop, and whole process is very fast and very flexible. So this is particularly used for large component and is best for long process times. Type is your ladder type layout. So in this particular flexible manufacturing layout, we have different workstations arranged in such a way that if we load our component from one point, so like our component is moving in this direction, so if we need some certain operation, then part will go to that workstation. So if we not require that kind of operation, then we will skip that step, and the part will move directly to that machine there, which one is required. So main advantage is that the required operations can be performed if so the machines are in such a way that the workpiece means it doesn't go to each machines, but it will go directly to that workstation only, which is being required only. So we save the time and we get the quick end product. So this is the advantage of this particular layout. So the sequence we can decide as per the required. So this is particularly ladder type layout. So fourth is open field layout type, where majorly we use that automated guided vehicle AGV. So this particular different AGVs are situated in one place. So like this is the one point where we feed our workpiece or raw material. So for loading we use that automatic guided vehicles. So these these have certain guided path. So they move from this direction. So as required, the the guided vehicle will move and it will feed to workpiece to that particular machine or workstation. So these particular different machines are arranged such a way that so as per the required that part is moved and automated vehicle will deliver that component particularly. So as that one we can see this the component are moving in that directions and this is a which deliver the component and after getting the operation it will deliver to the next workstation. So these are certain path where the IGV is moving. So again finally we have some like inspection unit where our inspection of the end product is done and finally we receive the completed component. So this process is more quick and more we can say complex layout is there because as per the required we can decide the flow and path and we can control our AGV. So there are the quick management and we can say as per the as per the modification or if you need some modification some process and sequence then we can implement quickly. Fifth type is robot centered layout. So in this layout we use a robotic arm as a we can see in between machine work table and machine tool we use the robot. So this particular robotic arm is used to place the parts like if you have some raw material these are moving. So as required this the robot will identify the parts geometry and it will feed to your machine work to machine tool and after the end it will place the workpiece. So the sequence and the mainly how the workpiece will be placed that will be decided by the robot itself. So so the robot is very helpful for quick operations. So with a major advantage is that the whole operation is performed without any error and we we save the that processing time. So in this photograph we can see the different layout type. This is like layout line type in factory. And this is you can say our AG vehicles are moving from one place to another place for fitting the mechanism. Another this is the robotic arm type, robotic robotic type layout. This is your ladder type. We can say our second type layout, a loop type where the track is in shape of loop and the I think it's a practical industrial operation. So here we can say in a CAD/CAM laboratory, this is the um, computer integrated system. So for there are two conveyor system. This conveyor one and conveyor two. So you can see how different components are connected, how these are performing for certain operations. So like if we have some certain components, so like we can understand first this one. So like we have conveyor. So this conveyor is operated by conveyor motor. So here we can start and stop this conveyor for moving certain components. So like if we are feeding some component is moving this direction, that component details is read by your barcode. So that the details is we can say is is sent to your personal computer, or that info is read by the robot, and then as the component will come to that robot, then it will see that if it is required some operation, then it will feed to your machine. So this is your one system. Another one is same way. If we want to detect that our met that our component is metallic or non-metallic, so there are some certain sensor are being used. So if we have some component, then the sensor will sense, and that will be read by your main PLC system. So if your component is metallic, then that sensor is use data. Again, if you have another sensor for non-metallic detection system, so again you have sliding robot, so that will that will work for both the side. So as per required, it will move from to its fixed path, and you can detect the different variety of components using that kind of system. So same data is recorded by your PLC system and PC system. This is the example of your simple and modern manufacturing system. So in a simple manufacturing system, you can say different units of machining center arranged in a line, and using your AGV, automated vehicle, the components are moving from one direction to another. So we have like different machines, units of machining centers, then some head indexer machines for different operations, then washing machine and CM for inspection, coordinate measuring machine. So this is your simple manufacturing system. For a modern manufacturing, like we have some raw materials, and automated vehicle are being used for transporting these raw materials to a different machines or workstations. Then again we have different assembly lines for assembling these different components. Then we have some finished machine cells to see the end product. So these are being arranged by or controlled by your host computer, as we have seen in computer controls system. So now we'll see the application of your flexible manufacturing system. So there are huge application of FMS for you can see the different in different domains, like in metal cutting operations or machining system. FMS is used in metal forming operations like bending machines, or in some kind of press, or you can say about deep door processing. So there are application of FMS, flexible system, in assembly lines, in joining, welding process. There is flexible system, service treatment processes, in inspections of different component, in testing of the materials, in forging process, in textile industries. There in semiconductor manufacturing industries, of plastic injection molding, all where there are applications of flexible manufacturing system. In this slide, we will discuss the advantages of FMS to reduce setup and QO time. So using this flexible management system, we can reduce the setup and queue time. We can reduce the inventory level. We can get the consistent level of qualities of your end product. Then it has greater flexibility in production scheduling. It improves the overall efficiency of the system. It reduces the time for for completion of a product. So we can say product cycle time reduces. It utilizes human worker better. It improve product routing, so we can get better product route for for in for individual product. So it produces a variety of items under one roof, improve the product quality level, serve a variety of vendors simultaneously, and produce more product means variety of product, or we can say that production level get high, so the time reduces and the production rate is high. So now in this slide we'll discuss what are the disadvantages related to your FMS. So initial that capital investment is presently high while setting up flexible system in current industry. So labor with the training and maintaining the knowledge of FMS system is very difficult to find. So that kind of labor which are skilled to your for managing the different workstations of FMS system. So that kind of labor is very much required, so we can't get easily that kind of labor. So cost of fixturing is very high, the conditioning monitoring is very expensive, that overall manufacturing is very sophisticated and complicated. So limited ability to adapt to changes in product and product mix is very problematic. It is expensive, substantial pre-planning activity. Now we will discuss the challenges associated with FMS. So the basic challenges are determining if the flexible manufacturing system is best production system for your company as a economically or socially. Second challenge is that possible expense and that cost associated with your implementing the FMS system. That is very challenging. Then day-to-day maintenance of FMS operation is very high. These are the basic challenges that are associated with your flexible manufacturing system. Now, related to your design or FMS layout design, we have certain issues. So first is workstation type. So workstation or managing the workstation or the, to design the workstation, the parameters associated with the different workstation for different operations is very typical. So as the variation is increased with process routing and layout, so increase the product variety, so that will move you from line type to open field type. So as the open field layout is very complex layout, so that is a design issue related with the FMS. Third is material handling system. So variety of materials, that handling of that variety of materials to different work part or different workstation is very tough. Then work in progress and storage capacity must be compatible with your process. So that is again very tough, or these are the issues with your FMS system. Then tooling number and types of tools, prioritization, tool duplication. So related to your tooling, the tool selection, tool material, types of tool for each station, that management is very tough. So the workpiece monitoring the status of your workpiece, different work part or different, you can say that assembly component of a complete part, complete system, that monitoring is very tough. Then pallet fixture, that your fixture design system and the flexibility, that is major issue in your FM. Then regarding your operations or working time, there are certain issues like like scheduling your master production schedule and dispatching. There are a lot of issues associated with this system because there are variety of components and parts. Then dispatching is very tough for that variety of components. Then machine loading system for loading the work part of to that machine from storage to that is very tough. Then part routing, then decision of that route where each part will go to different workstations, that is very tough. Then part grouping as per their different geometry, their design for grouping, that is very tough process. Then tool management for decision of tool material and their sequences, then that task is very tough. Then pallet and fixture location is also very much tough. So in a last slide, we will discuss the conclusion part of both the part. So as we have discussed the whole FMS process, so we can see that this is a revolution in the field of manufacturing technology for speeding up the process and for more accurate process and for to get more reliable and high quality product. So this that FMS flexible system can be designed to meet this specific demand of the each industry or company, so that is used for multitask operations and it requires substantial investment of time and resource, that is very much required. So this is the all conclusion of the FMS part.